Assalamu alaikum students, how are you all? I hope you all be fine and healthy. Wishing for your good health. As it is the first session, first lecture, online lecture for your chemistry ninth class. And today we will be discussing the think tank of the chapter number 1 given on page number 29. I recommend you should open your books while you are getting this lecture and a notebook as well, so that you should carry on side by side, and it would be easy for you and it would be very understandable. For what I think that is all these 6 questions are there total, and I think all 6 questions should be very clear if the basic concepts are very clear in your mind. So, and the basic concepts in the first chapter you very well know that it's about moles, molar masses, and about Avogadro number. So if these 3 concepts are very clear in your mind, these 6 questions would be very easy. So getting on the question number 1, what mass of sodium metal contains the same number of atoms as 12 gram of carbon? So I think this has been discussed so many times in the class that the number of particle is always proportional to the number of moles a certain substance have. Okay, we have discussed that. For example, I have discussed this so many times that why a certain atom would have the same number of atoms with this gram of any particle. So if 12 gram of carbon is equivalent to the 1 mole, okay, as we know that 1 mole of any substance contains 6.02 number of particles, and this 6.02 number of particles is the Avogadro number. So if in 1 mole of carbon the atomic mass is 12 gram, similarly, 1 mole of sodium metal have the atomic mass of 23 grams. So, we can say that the 12 gram of carbon and 23 gram of sodium metal would have the same number of atoms. I hope this would be clear to you. Second question, what mass of oxygen contains the same number of molecules as 42 gram of nitrogen? So, what is happening here? That we have to calculate that how many moles are there in 42 grams of nitrogen. Okay, we have to find out that how many moles are there in 42 grams of nitrogen. So for finding that, we have the formula of moles is equals to mass in grams divided by the molar mass. This is the very common formula, and I think you all are very well known about that, and I think you are very clear about what is molar mass. So for molar mass for a compound is the gram molecular mass. So here nitrogen, it is being present in N2 form. Okay, N2 means a molecule. So N2 means 2 into a gram atomic mass of nitrogen, which is 14, and which will be equal to 28 grams. So putting the values in this formula, moles is equals to 42. The 42 is given in your question, divided by 28, and it will be equal to 1.5 moles. So we know that 42 grams of nitrogen contains 1.5 moles. So we will calculate that what mass is there for 1.5 moles of oxygen. So 42 gram of N2 contains 1.5 moles. Same number of moles of oxygen will contain the same number of molecules. So 1.5 moles will have the same mass, and this mass will be calculated by the same formula. Moles is equal to mass in grams divided by molar mass. We have to rearrange it again. Moles into molar mass. Mass in gram will be equal to moles into molar mass. So moles were 1.5 into molar mass, that is 32. Oxygen have the atomic mass of 16. O2 means 2 into 16, and it is 32, and it will be equal to 48. So we can say that the 48 grams of oxygen will contain the same number of molecules as 42 grams of nitrogen. I hope this question would also be very clear to you, and as it is based on the previous concepts, I am wishing that it should be very clear. So going on to the next slide, which is the next question number 3. Calculate the mass of hydrogen in grams. Now, what are they asking? They are asking the hydrogen atom. Okay, atoms, when the question is reminding about atoms, it means it's something about the number of particles, so we have to calculate the number of particles first. Okay, so mass of one hydrogen atom can be calculated by the formula number of particle is equals to mole into Avogadro number. So number of particles will be equal to mass in grams divided by molar mass, because this is the mass in gram over molar mass is the formula of moles, which will be equal to mass in grams divided by the molar mass into Avogadro number. So mass will be equal to number of particles into molar mass divided by this Avogadro number, 6.022 into 10 raised by 23. So putting the values, number of particles, how many number of particles were there? Only one hydrogen atom. The 1 into molar mass of hydrogen was 1.008. So they became 1.008 into 6.022 into divided by 6.022 into 10 raised by 23, and the answer was 1.674 into 10 raised to power minus 24 grams. Okay, so the mass of one hydrogen atom would be this. I hope it would also be very clear to you. The next slide. So this is why I have asked you, please open your books with you. On page number 29, there is this picture given on your book, and that picture has a sample, and it is a sample of air. And the question is about that sample. Okay, most of the questions you have to do it by yourself, and I would ask you the questions when we will be holding our normal classes about this. This all has been done earlier about the number of particles. Okay, the particles in the picture, there are different shapes. One certain shape would be considered as one type of substance. So in total, for the question number 4, part A, count the substances shown in the sample. A certain shape would be providing you a single substance. So there are almost 5 substances in the sample. Now for the question number 4, part B, is air is a mixture of pure substance explained? It is very clear to you all. This we have been doing very much for very much time. I think this has been on your fingertips that the entire physical world is made up of mixtures of compounds and elements. So air is also a mixture of compounds and element, and as everything, for example, air have oxygen, water, carbon dioxide, noble gases. Okay, these are all gases which are present in air, and all of them are in a single phase. Okay, you know the homogeneous and heterogeneous mixture. In heterogeneous mixture the phases are different, but in homogeneous mixture the phases are single phases, as they are all mixed together in a uniform composition. So air is a homogeneous mixture. Okay, I think this would be very clear. So next part, I'm sorry, there's like it's been A again, but identify the formula of each substance which is present. It is nitrogen, oxygen, H2O, carbon dioxide, and argon. If you are very clearly observing the picture, the symbols are written on those particles. Okay. This question you have to answer by yourself. Argue whether each substance in air is an element or a compound. The key point to this question is this: is air is a mixture or a pure substance? Okay, so you have to give me the answer after this. After listening to this presentation, you have to submit your answer while writing it on your notebook. I don't mind if you are using the notebook you are already using, or do it on the loose pages, but I recommend to do it on the loose pages. Okay, answer the question, and then make a picture of it and send it on the Facebook account where we have been doing this all. Okay, or during in the comment section, you can paste the picture on the comment section. I would recommend you to do this, or you can also write it on your loose sheets, and I will obviously after the summer vacation we will be I would be checking your summer vacations homework. You all have to do this all questions on the summer vacations homework, but this you have to argue by yourself. And the key point is the reference. You can take the reference from your book, the topic entire molecularity of the physical world, and page number is page number 10. Okay. Now last question, which is the most common substance in air? If you will uh, observe that more clearly, that figure, you will see there is particles with two circles, n and 2. It is found mostly in that figure. So we will say that N is N2, nitrogen. So nitrogen is the most common substance in air. I hope this question would also be very clear. Moving to the next question, question number 5. This is a very, there's a tactic in this question. They have given you the mass of whole molecule, water, H2O. Calculate the number of hydrogen atom in 18 gram of H2O. They have given you the mass of for the whole molecule, and they are asking you the number of hydrogen atoms. Okay, now we will see that 18 grams of H2O is equals to 1 mole of H2O. When there is 1 mole of H2O, it means how many particles are there? 6.022 into 10 raised by 23 molecules are there. So, for example, in the formula, how many hydrogen atoms are there in 18 grams? It is 2 hydrogen atom, H2. So, as mentioned in the molecular formula, the water, there is 2 hydrogen atoms. So, 18 grams of 1 mole of water would contain 2 into 6.022 into 10 raised by 23 atoms, and you have to calculate the answer, and the answer would be 1.204 into 10 raised by 24. You have to calculate it by yourself. Please do it by yourself. I would really recommend, because you know me, I cannot give you all the things on I cannot do the spoon feeding for you. Okay, so you have to calculate by yourself. I have given you the key point. Question number 6, same as question number 5. You have to do it yourself, DIY. And the key point, it is same as question number 5. As water contain 2 hydrogen atom and 1 oxygen atom. What is the question number 6 first? Calculate the total number of atoms present in 18 gram of H2O. So the ratio of elements in water is 2:1, like 2 hydrogen atoms and 1 oxygen atom. So 18 gram of water would have 3 atoms, and this would be like 3 into 6.022 into 10 raised by 23 atoms. Okay, I hope you would do it by yourself, because I think these all concepts are already very much clear, and don't think there should be any kind of doubt in that. Okay, now moving to the next one. Yes, how can I leave the task? Solve question number 6, and you have to solve the other 2 questions which I am writing on this presentation, and you have to do it on your loose sheets. Okay, do it on your loose sheets, and please do not copy anyone else. I know the technology is very clear, very great, and obviously you can take the help from others, but that's why I have given the questions by my own. I have changed the values. Okay, calculate the number of atoms present in 150 gram of water. Okay, what is that? Here it is 18 gram of water. 18 gram of water, I have changed it to 150 grams of water. You have to calculate the number of atoms. What mass of carbon dioxide would have the same number of molecules as that of 48 grams of oxygen? You have to do this all by yourself. I would recommend you to clear your concept as much as possible, and thank you so much. Thank you so much, students, for your time. Good luck, be safe and be healthy. This is your healing time, your self what is that, reflection time. I hope you would enjoy this time while studying as well. Thank you so much for your time.